Hello everyone, and welcome to lesson 3.6. We're going to be talking about perpendiculars and distance today. Alright, and by distance I mean the distance formula. So if you've forgotten that, now's a good time to brush that off. Now, when we're talking about perpendiculars, we are talking about perpendicular lines. So beforehand, we've been talking about parallel lines. We haven't really addressed perpendicular yet. So that's what we're doing today. Now, I will say this 3.6 is both the book section and the online section. So we finally match up for once. Let's go ahead and get started. Bit of background. Okay, so this is an odd little section here, so let's go into some background on why it's needed. Now, like all math, perpendiculars and distance takes its place in history and, more importantly, construction. Okay, so when you had in Egypt days, all right, in ancient Egypt, they wanted to establish vertical lines when building the pyramids. Okay, straight lines are important when it comes to construction. Being precise is important. Now, this plume bomb thing they used is a way to use gravity to establish vertical. Okay, because gravity will always pull straight down. And so what you had is you had a string suspended with a weight at the bottom. Okay, so someone would have like a fishing pole of sorts, and there's a string that has a little weight at the bottom. And it didn't matter where you held this fishing pole, the weight would always hold the line vertical. Thus, it would always be perpendicular to the ground. Okay, so you could be on an incline, you could be on a flat surface, didn't matter. They would swing this string around, and it would swing back and forth, but it would always settle going straight up and down because gravity would always pull it vertically, and that's how they found the perpendicular distance, or the perpendicular line, to the ground. Okay? Now, the reason why this is important, like I said, is because in construction, that straight line is very important. All right? You want to be able to build on the flat surface. You want to be able to build in accordance to gravity, but it also mattered for distance. Okay? So if you've got 2 points, let's say you've got a bush right here. It's a bad bush. It's a bush, though. Let's say you got a bush right there, and then you've got a river. All right? And you want to cross the river, but the river's too wide. And there's a tree over here. It's a much better tree. Okay? In construction, you would want to build a bridge going across this river, or construct a rope bridge going from the bush to the tree. All right, but it does you no good to throw a rope or to build a bridge that goes over here and then lags around and comes over there. It's not a very productive construction site. What you would want is the shortest distance going straight across, which is going to be your perpendicular distance. All right. Also, it mattered. So when you're doing perpendicular distance, again, you are looking for the shortest distance between a point and a line or a plane or another point. Okay, that was the whole point of the plume bomb thing, is to find the shortest distance in all cases, because the shortest distance is the perpendicular distance. Okay? Now here's the postulate that spells that out, because in math we have Simon Says rules. The perpendicular postulate states that if given a line and a point not on the line, there exists exactly one point that is perpendicular through the line. So if basically what this is saying is if I am given line M and point P, there is only one line that is perpendicular to line M that goes through point P. That's all this postulate is saying. So let's go ahead and practice this. Now, it's not just enough to know that there exists a perpendicular line between a point and another line. Sometimes we are looking for the distance between the point and the line. And as we mentioned earlier, the perpendicular line is the shortest distance. So this is actually a two-step problem here. What you're going to do first is you're going to find the perpendicular line from the point to the line. And then your second step is going to be to measure that distance using the distance formula. Let's go ahead and get started. Now, in this picture, we have line L, which is right here, that contains the points -5, 3, and 4, -6. I want to find the distance between line L and point P over here. Okay? So I want to find this distance is what I'm looking for. Now, as I mentioned earlier, this is really a two-part problem. The first part is going to be to find the perpendicular line. The second part is going to be to find the distance of that line. All right? So here we go. Now, the first step in my part 1 over here is to find the equation for line L. All right, so I gotta find the equation for line L. I'm gonna use my 2 points. I'm gonna come up with an equation. So first, I need slope. So I'm gonna use my slope formula. So y1 minus y2 over x1 minus x2, x1, y1, x2, y2, and I'm gonna plug this in. So my slope turns out to be -1. As you can see, I plugged it in and solved over here. Next, I need to find the equation for my line. Now, there's 2 ways you can do this. Number 1 is you can plug into slope-intercept form, or we can plug in to point-slope form. And I'm going to use point-slope form because I have my slope and I have 2 points. So I'm going to pick my first point and plug it into point-slope form, which, as a reminder, is y minus y1 is equal to m times x minus x1. So here we go. And there's my equation. Y is equal to -x minus 2. Okay, so that is the equation for line L. So far, so good. Next, I need the perpendicular line. Okay, so part 2 of my step 1 is to find the perpendicular line to line L. Now, when you're looking for perpendicular, you have to look at the slope. So if I have parallel lines, it's going to have the same slope. If I have perpendicular lines, I'm actually going to look for the opposite reciprocal. So what I'm going to do is I'm going to take m for the perpendicular slope, and I'm going to flip it. So now it's 1 over m, and I'm going to change the sign. Okay, so as a few examples, I'll do this up top in black so you can see it. If my slope was 2, my perpendicular slope would be -1/2. If my slope was a -3/5, my perpendicular slope would be, actually these should be arrows, not equal signs. My perpendicular slope would be a positive 5 over 3. I didn't flip it. Okay, a positive 5 over 3. If my slope was 1, or -1, then my perpendicular slope would be a positive 1. Okay, so in order to find the perpendicular slope, you're going to flip the original slope and then negate it. In this case, my original slope is -1. So m is equal to -1. Therefore, my perpendicular slope is going to be 1. Okay? Now, I'm looking for the line parallel to L that goes through point P. Okay, so I'm going to add on to this. It needs to go through P, which is 2, 4. So I'm going to do the same thing I did in my first step, and that's going to use point-slope form to find the equation of this perpendicular line. And there's the equation for my perpendicular line. Notice I used my point P and my perpendicular slope in point-slope form, and I solve for the perpendicular line, which is down here. All right, now that I have my regular line and my perpendicular line, I can move on to the second half of the problem, and that's actually finding the distance between the point and the line. Now, the first step in our second part, so step 1 over here, is to find Q, or find the intersection of the 2 lines. Probably not how you spell that word, but it's okay. We're moving on. Now, you might have been looking over here off to the side at this graph that I've been labeling every so often, and you're like, Miss Stockton, point Q is right there. It's easy. We can just count and find it. Okay, my answer to you is yes, but you're not always going to have the graph. Okay, so the first step in finding the distance between the point and the line is you have to find the point where the two lines intersect. That's going to be point Q. Now, this is the point where both lines intersect, so the x and y values are going to be the same in both lines. As you can see over there, on point Q, both lines are at the same point. So, since the x and y values of the two lines will be equal at this point, what I'm going to do is I'm going to set the equations of my perpendicular line and my original line equal to each other. And then I'm going to solve for my x value. All right, and I get x is equal to -2. Then I'm going to take this x value and plug it back into one of my equations. It doesn't really matter which. And that's how I'll get the y value. So I'm going to plug it in to my perpendicular line over here for no other reason than because I have positive numbers, and I like positive numbers. So I'm going to rewrite the equation. I'll do it in red so you can see it. And my equation is y is equal to x plus 2. And now I'm going to plug this to x into my equation. And I have y is equal to -2 plus 2. Y is equal to 0. Now, if you're looking at the picture, you can see this matches up, which means my point Q is going to be -2, 0. And it does match with our graph, so far so good. Now, last but not least, the final step in our whole problem, and that is to find the distance. Finally, between point P and point Q. Okay, so in order to use the distance formula, you need 2 points. Okay? We were given the first one with P, but we didn't know what our second point was. That's why we had to go through steps 1, 2, and we can even name this one up here 3 to figure it out. We had to find our second point so we could go ahead and do the distance. Now, as a reminder, the distance formula is over here. The square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? So now you have both of your points. This is x1, y1. This is x2, y2. I'm going to plug everything into my distance formula and then solve. And there's our answer. The distance between point P and line L is 4 root 2. All right. Now at this point we have finished. There is our answer. 4.2 is our distance. But what I want you to do is take a small step back and just look at the amount of work we had to do to find that number. Okay? These problems do require a lot of work. However, look at all the math we did. As far as basic math goes, there wasn't a whole lot of hard problems. Okay? In our first and second steps, it was basic addition and subtraction. Even in our third step, basic addition and subtraction. Okay? So the hardest part of this whole process is going to remember that it's a 4-step process. Okay? So it's more of a concept than an actual math problem. But if you can remember the concepts, if you can remember the different steps, then the basic math to get through those steps is not very hard at all. All right, let's keep going. We're almost done. Now, in the previous problem, we were finding the distance between a point and a line. Well, what about the distance between 2 parallel lines? Say you have a ladder and you want to know how long those rungs are. Say you have a suspension bridge and you want to know how long the supports are. okay? Or a river and you want to know how long your bridge is going to be. All of these are examples of if you have two parallel lines and you want to know how far apart they are. Now, the nice thing about having two parallel lines is the distance between them will always be the same at any given point. It's what it means to be parallel lines. So you really don't need to find the distance of AC or AB, DC, EF. All you need to do is find a point on one line and a point on the other line, and then you've got your distance. Now, because we're not given an extra point, so if you paid attention to what I was saying just then, I said you had to find a point on both lines. Because we're not given that extra point, there is an extra step on these problems, but it's not that bad. Let's practice. All right, here's our example. Now again, that picture is there for your convenience, but we're going to go through the problem as though you didn't have the picture. So here we go. We need to find the distance between the parallel lines M and L with the equations y is equal to 2x plus 1 and y is equal to 2x minus 3, respectively. So that means that this equation right here is L, and this equation right here is for M. Now, let's do a quick review of what it took to solve the last problem. Okay, our first step was we needed to find the equation of the first line, or the given line. I'll erase that and put given line. All right, next we needed to find the perpendicular line. All right, and this required a point, so this needed an extra point. In the last problem, we were given it. Then our third step was to find Q, okay, or the intersection, okay, or the intersection of the two lines. And then finally, our last step was to use the point, so I'll call this point P still. So find the distance between the 2 points. All right, now let's see how we're going to adjust this process for the two parallel lines. Now, in this problem, we're already given two lines. We're given line L and we're given line M. So, yay, step 1 is already done. However, as we get to step 2, we need that extra point, okay? Because in order to find the perpendicular line, we need a point in order to find that line, okay? We're going to plug into point slope form, so we need a point. All right, so what I'm going to do is I'm going to pick one of my lines, and I'm going to find a point on that line. It doesn't exactly matter what point I use. All I need is to pick one of my lines and to find a point. So here we go. Step 1, find a point, or pick a point on the given line. All right, and in this case, I'm going to pick line M. And the reason why I pick line M is because our picture over here gives us a point on line M. Okay, so I'm going to go ahead with march with the picture. But another way you could do this is just to see where your intercepts are. So you notice how the point over here on the graph, this is our y-intercept. Okay? Our equations over here are given in slope-intercept form, which means y is equal to 2x minus 3. Our y-intercept is going to be 0, -3 back here. So we actually didn't need any math. All we needed was the y-intercepts of one of the lines. So we can even change our instructions to say that. And there we have it. So now that I have my point, I'm going to move on and finish step 2 to find the perpendicular line. Okay, so I'm going to find the perpendicular line using that y-intercept. So I'm using this point, and I want to see what the equation of this line over here is. I'll call it, or they call it, line P. Okay, so we're finding our perpendicular line. Now, I need my slope. My slope of the original was 2, therefore my perpendicular slope is going to be a -1/2. So there's my slope, there's my point. I'm going to plug into point slope form and solve for my line. And here is my perpendicular line. Yay! Alright, so now that we have our perpendicular line, we need to find the intersection of the perpendicular line and the other parallel line. So to show you over here on our picture, we picked this point right here because it was the y-intercept and it was nice and it was easy. But I am looking for this distance. Okay? And in order to get distance, I need 2 points. So my next step needs to be to find this point right here, which is the intersection of our perpendicular line and the other parallel line. So that's going to be step 3. And here's where it gets important, because we need to pick the other parallel line. So I need to make sure I'm using L to find my intersection. All right. Now, remember, to find the intersection of the line, all we have to do is set the 2 equations equal to each other. So I'm going to take line L, 2x plus 1, and set it equal to my perpendicular line. And now all I have to do is solve for x. Now I'm going to get rid of my fraction in my first step. So I'm going to multiply my entire equation by 2, and that's going to cancel out my fraction. So I have 4x plus 2 is equal to a -x. Okay, that was the whole point, is to get the fraction out of the way. Minus 6. Okay, and now I'm going to solve for x. All right, there's my x. And so I'm going to plug back into one of my equations and solve for y. I'm going to plug back into L for no other reason than because it's a simpler looking equation. But you could have plugged back into the perpendicular line. It doesn't matter. Whatever line you plug back into, you're going to get the same answer. So here's my L line. So y is equal to 2. I'm going to plug in my x. -8/5 plus 1. And I'm going to solve for y. And there is my point Q, or the intersection between the perpendicular line and the last parallel line. We are almost done. We are down to the last step, and that step is to find the distance between the 2 points. Now, which 2 points? Well, the Q we just finished solving for, and our original point. Okay, so I'm going to plug both of these points into my distance formula, and I'm going to solve from there. Okay, so last but not least, our final step. I'm going to write it up here because I ran out of room down there. Step 4. Find the distance between the 2 points. Oops, can't really see that, so I'll change colors to do my math. All right, so I'm going to plug everything into the distance formula. But first I'm going to label. So I have x1, y1, x2, y2, and I'm going to plug everything into my distance formula, which, as a reminder, is down here. All right, here we go. All right. So most likely, if you braved the fractions, you got to this number right here, which is the square root of 16 over 5. Now, I'll simplify this with you together so you can see what happens. Now, when you have the square root of a fraction, you're going to take the square root of the top and the bottom. So this ends up being 4 over the square root of 5. However, you can't have a square root in the denominator. So we're going to rationalize the denominator by multiplying the top and the bottom by the square root of 5. And this is going to get it out of the denominator. I now have 4 root 5 on top and 5 on the bottom. This is the distance between the 2 parallel lines. A lot of work for a weird number, but something I want you to take away from this problem is, again, the math was relatively simple, all right, but your answers are allowed to look weird. That is still a number. 4 root 5 over 5 is still a valid number. Don't get scared off just because it's not a whole number. All right, it makes sense. Look at the picture, okay? If you actually were to plug that number into a calculator, you would get 1.78 something or another. Okay, so it's very close to 2. If you look at our parallel lines, it's about 2 units apart. So our number matches the picture we're given. And so the answer is valid. You just need to trust yourself that once you do all this work, if you don't have any math errors, that is still a valid answer. All right, well, this is the end of the PowerPoint. Please let me know if you have any questions, and I will see you next time. Bye.